Welcome to another video. A taxi is travelling along a straight road at 4.8 meters per second. At t is equal to 0, the taxi passes a boy standing on the pavement. The boy starts running in the same direction as the taxi, accelerating at 0.8 meters per second from rest for 8 seconds. He then runs at a constant speed until he catches up with the taxi. Part A. Draw a velocity time graph using the same axis for both the taxi and the boy. Determine the time in which the boy is running at the same speed as the taxi. Find the maximum distance between the taxi and the boy. And find the distance the boy has run when he catches up with the taxi. Okay, so part A, we've got to draw a velocity time graph. So we need a horizontal axis for time, a vertical axis for velocity, the units there, seconds and meters per second. Now, we'll start with the taxi. So the taxi just moves at a constant speed of 4.8, or constant velocity of 4.8. So that will just be a horizontal line like that. We'll mark on 8 seconds because the boy is accelerating for the first 8 seconds at an acceleration of 0.8 meters per second. So for the boy, using suvat, v is equal to u plus at, and we can use suvat because the acceleration is constant. The initial velocity is 0 because he starts from rest, so v will be 0 plus 0.8 times 8, which will give me 6.4. So at here we can mark on 6.4 and we draw a straight line like that, and that represents the acceleration. And then he moves off on a constant speed of 6.4 for the remainder of the journey. Okay, so part B, we want to find where the boy and the taxi are at the same speed, which will be this point here. Okay, so the boy is running at the same speed as the taxi when 4.8, now this line here has an equation 0.8t, we can get that from suvat, is 0.8 times t. And we just solve that equation and it'll give me that t is equal to 6 seconds. Right, when t is equal to 6, that will be the time when there will be the maximum distance between the taxi and the boy, because after this point he catches up. And at this point here, the taxi is moving faster than the boy, so it's moving further away. So the maximum distance occurs when the boy and the taxi have the same speed, when that's t is equal to 6. So we draw our velocity time graph again. So the point we're interested here was when t is equal to 6. So the area under the graph gives distance. So for the taxi, that will be 6. So it will be this rectangle here. It will be 6 times 4.8, which gives me 28.8 meters. And then for the boy, this will just be that triangle. So it will actually be half of that distance. So half of 6 times 4.8, which is 14.4 meters. That's the distance they travelled up to 6 seconds. So we want the difference of that. So the maximum distance will be the difference, which will be 14.4 meters. And later on I will show you a displacement time graph for this problem as well. Right, so for the last part, we need to find when the boy catches up with the taxi. So we'll let that point be t, capital T, be the time when the boy catches up with the taxi. We'll just mark that on our graph. Okay, so as distance is given by the area, we want the area of this trapezium to be the same as this area of that rectangle. So the areas under both graphs must be equal. So for the boy, that's a trapezium. So a trapezium is you add that side to that side, multiply by the height and take half. So this will be t minus 8, and this will be t. Okay, and the height will be 6.4. So it'll be a half of t minus 8 plus t times 6.4 is equal to the area of this rectangle, which is 4.8 times t. That's for the taxi. We just need to solve that equation. So half of 6.4 is 3.2. 2t minus 8 is equal to 4.8t. So 6.4, spanning the bracket, 6.4t minus 25.6 is equal to 4.8t. That gives me 1.6t is equal to 25.6. It gives me that t will be 16 seconds. So in order to find the distance travelled, we'll just use the taxi one, because it's easier. We'll just do 4.8 times 16, because they're both at the same point at that thing. So the boy has been running 4.8 times 16, which is 76.8 metres. Now, we weren't asked to do this, but we can look at a displacement time graph for this problem, which will look like this. So here we have the taxi. That's just going to be a straight line. It's getting a constant. Here we have a bit of a curve because we had an acceleration, and then a straight line for the constant speed. We can see that they actually meet each other again at 16 seconds at 76.8. This is the function of displacement for the boy. This is the displacement function for the taxi. So if we move the value of t along here, we can see that they get further and further apart, and then they get closer to each other. Okay, so the greatest point where they are furthest away will be there when t is equal to 6 seconds. That will be 14.4 meters, like we calculated already. Just before, it's going to be less, and so we can analyze the motion using this graph. So this app graph I will put in the link of the video. Okay, so this has been a video to look at a boy running after a taxi problem. I hope you have enjoyed this video and learned something, and you could consider subscribing to my channel. And in the notes of this video, I'll put the link to my website, where I have absolutely thousands of maths videos like this. Thank you very much for watching.